Greetings, everyone. Today we're going to continue our lesson of imaginary numbers, but now we're going to solve by imaginary numbers. We're going to combine everything we've learned so far, which includes finding the greatest common factor, grouping when you have 4 terms, AC method when you have 2 terms, a difference of squares. Remember that 3 things need to be present. You need 2 terms, you need to be able to square root both terms, and you need to have a minus sign. We've also solved by square roots, and in that we've had to reduce radicals, meaning a good root and a bad root, or a perfect square and a non-perfect square. We've had to rationalize the denominator, which occurs when you have a radical in the bottom. And we've dealt with imaginary numbers, which come from having a negative under the radical. Let's take a look at this example. My first thought is to see if difference of squares works. I can square root both sides. I have 2 terms, but I do not have a minus sign. Therefore, I cannot use difference of squares. So in this case, we're going to isolate the x, and we want to solve using the rules of square roots and imaginary numbers. I'm going to take care of that 9 first by subtracting it from both sides. I'm then going to isolate the x by square rooting both sides. Remember, the second you square root, you need to have a plus or minus out front of that radical. Next, I'm going to take care of that negative under the radical, which comes out and becomes an I. I can then take care of the radical itself. Square root of 9 is 3. Now, as we know, if we have the variable x, we don't say x3, we say 3x. So we want to arrange that in the correct order and say plus or minus 3i. Make note, my highest exponent is 2, and I have 2 answers, and that's what I need. Let's take a look at this example. I put stars by this example because there's something unique, as it has a 4th power and a 2nd power. In the grand scheme of things, I have 3 terms, so I want to see if AC method will work first. I don't have a GCF, as there is not a common number I can divide out or a common letter that they all have that I can divide out. So let's start with our AC template. A times C, B goes on the bottom. A times C is negative 64. B value is 12. I need 2 terms that multiply to get negative 64, but add to get 12. 16 and 4 are 2 terms, but I have to watch my signs. So in this case, the 4 is going to be negative. This is our first checkpoint, so let's check our work. 16 times negative 4 gives me negative 64, and 16 minus 4 gives me the 12 I need on bottom. Remember what multiplies and what adds. So we're going to take that middle term, and it's going to become the 2 values we found, a positive 16 x squared and a minus 4 x squared. So notice the difference from the other AC problems that we've solved before. If the middle exponent is 2, then my middle terms still get an exponent of 2 on their x values. That's the only reason why I started this problem, is because of those exponents. Everything else is the same as all of our other lessons. So I want to group because I now have 4 terms. Out of the first set of parentheses, I can divide out an x squared, which leaves me with x squared plus 16. In the second set of parentheses, they're both negative, so divide out a negative, and they have a common factor of 4. which leaves me with an x squared, and negative 64 divided by negative 4 is positive 16. I ended up with the same thing twice, which means that is now my common factor that I can divide out. And I'm left with an x squared minus 4. Now if I take a look at these two factors, they both have two terms. They both can always square rooted, but this is the only one with the minus sign. Therefore, I can take that factor and break it apart, meaning keep the x squared plus 16 as is. But if I square root x squared, I end up with x. If I square root 4, I end up with 2. And because it's a minus sign, I do plus minus. That's the difference of squares. That's in the last page of your foldable if you need to look that up. Now I've simplified every set of parentheses as far as I can with the factoring rules that I know. So now I'm solving for x. So I'm going to take every factor and set it equal to 0. Let's take care of the easy ones first. Here I end up with an x equals negative 2, and here I end up with an x equals 2. Now over here, I want to isolate the x. I'm going to subtract 16 from both sides. I'm left with x squared equals negative 16. I want to isolate the x, so I'm going to square root both sides, which leaves me with x equals plus or minus, don't forget that, square root of negative 16. The negative becomes an I, the plus minus comes down, and square root of 16 is a perfect square. Square root of 16 equals 4. So the square root of negative 16 simplifies down to a 4i. Take a moment to check. My highest exponent is 4. I have 1, 2, 3, 4 answers, which is what I needed. The plus minus accounts for 2 answers there. Let's take a look at this one. I have 2 terms, but they definitely can't square root both sides. So in this case, let's start off with our basic rule of GCF. I can divide out an x from both terms. In this case, I really can't simplify that parenthesis down any further. So what I've done is actually created my 2 factors. So I'm going to set each factor equal to 0. Now this factor matters. That is an answer. X can equal 0. Over here, I have to isolate the x. So I'm going to subtract 2 from both sides. I'm going to square root both sides. When you square root, you have to remember your plus minus. That negative underneath comes out and becomes an I. And square root of 2 doesn't reduce, doesn't simplify down, so I'm going to leave it as square root of 2. If I take a look at my original question, it has the highest exponent of 3. I have 1 answer, 2, 3 answers. Let's take a look at this example. Key things to remember here. You can't distribute the exponent. We compared that in class and in a previous lesson on why we can't distribute the exponent. Never ever try to do that. Also, we can't distribute the 2 because there's an exponent. So also watch out for that. I can't distribute the 2 because of that exponent. So when you have parentheses with an exponent, you have to be very selective of the rules that you follow. In the end, it's just safer to follow the same rules we've done on all of the others, and that is isolate the x. Just slowly move everything to the other side. So I'm going to start off by adding 1. That's the only move that I can take care of right away. I can then divide both sides by 2. Oops, I took care of the 2 there. I end up with a negative 27. Next, to isolate the x, I'm going to square root both sides. Because the whole thing is under a squared, I'm going to square root the whole thing, which leaves me with an x plus 13 on the left and the square root of negative 27 on the right. Don't forget, the second you square root, I need to see a plus or minus. Next, we have 2 options. We can take care of this 13 or we can take care of this radical. The radical looks a little messy, so let's take care of that first. First of all, I've got a negative underneath, so I'm going to start by bringing out my imaginary value. I'm just going to keep dragging this x plus 13 down. Next, 27 isn't a perfect square, but it does reduce. And in this case, a perfect square that divides in evenly is 9, which leaves me with 9 times 3. Square root of 9 is 3, but instead of saying I3, we say 3i, with a radical 3 remaining. That's my bad root and good root. Now, I've simplified that right side as far as it'll go. So my only option at this point is to subtract 13. Well, I don't have any like terms, so I can't subtract the 13 from anything. So I'm just going to leave it on the outside, negative 13 plus or minus 3i radical 3. Now we write that negative 13 out front so that it's in standard form of a complex number. Standard form says that the real part comes first and the imaginary part comes second. For your homework for this section, make sure you check Google Classroom. Also know that this is a challenging unit. This is almost all brand new concepts. Think about when you know the lyrics to a song. You don't hear it once and know the whole song. You have to hear it over and over again and sing it and do it over and over again before you know the song. Similar with math concepts, you want to work on those concepts and practice them over and over to get them. So I also suggest watching these videos or participating in these lessons more than once. If you need any extra help, make sure you make it a point to see me after class.